Bismillahirrahmanirrahim. My name is Husnain Ali. I am from Department of BS Biotechnology and the topic of my presentation today is Palladium. First of all, we will discuss some definition and few properties of Palladium. Definition. Palladium is a chemical element with the symbol Pd and atomic number 46. It belongs to the platinum group of elements and is classified as a transition metal. Palladium is a lustrous silvery white metal that is known for its versatility and wide range of application across various industries. Properties of palladium. The physical properties include color. Palladium has a silver white color similar to platinum luster. It possesses a bright metallic luster. Melting point. Palladium has a high melting point of approximately 1554 degrees Celsius. Boiling point. It has a boiling point of approximately 2963 degrees Celsius. Density. The density of palladium is 12.023 grams per cubic centimeter. Ductility. Palladium is highly ductile, which means it can be drawn into thin wires without breaking. Malleability. It is also malleable, allowing it to be hammered or rolled into thin sheets. Now we will discuss some chemical properties. Atomic weight. Palladium has an atomic weight of 106.42 atomic mass units. Atomic number. The atomic number of palladium is 46, indicating that it has 46 protons in its nucleus. Electron configuration. Palladium has an electronic configuration of krypton 4d10. Oxidation state. Palladium can exhibit various oxidation states including +2, +4 and occasionally +6. Reactivity. Palladium is a relatively unreactive metal and is resistant to corrosion, tarnishing and oxidation. It is stable in water and air. Other properties include conductivity. But palladium is an excellent conductor of heat and electricity. Catalytic activity. Palladium exhibits exceptional catalytic properties and is widely used as a catalyst in various chemical reactions. Alloy formation. Palladium is readily formed alloy with other metals including platinum, gold, silver, and copper, which enhance its properties and expands its range of application. Now I will tell about you some discovery and history of palladium. Palladium was discovered in the early 19th century by the English chemist and physicist William Hyde Wollaston. In 1803, while working with platinum ore, Wollaston noticed a new metal with unique properties. He initially named the metal palladium after the recently discovered asteroid Pallas, which itself was named after Pallas Athena, the Greek goddess of wisdom. Wollaston's discovery of palladium was an important milestone in the field of chemistry. At the time, platinum was known, but the presence of other metals in platinum ore made it challenging to isolate and study individual elements. Through a series of chemical processes, Wollaston was able to extract and purify palladium, separating it from other platinum group metals. Initially, palladium had limited practical application beyond to its use in decorative objects and jewelry due to its scarcity and relative unknown status. However, as further research and understanding of its properties progressed, palladium began to find industrial application primarily driven by its catalytic properties. Here are some industrial applications of palladium. Palladium finds extensive application in various industries due to its unique properties and catalytic abilities. Let's explore some of the key industrial applications of palladium. Automotive industry. Palladium is critical component in catalytic converters used in internal combustion engines. It acts as a catalyst, facilitating the conversion of harmful pollutants such as carbon monoxide, nitrogen oxides, and unburned hydrocarbons into less harmful substances like carbon dioxide, nitrogen, and water. Palladium based catalysts are effective in reducing emissions and meeting stringent environmental regulations. Electronic industries as used in capacitors and connectors. Palladium is used in the production of capacitor which stores and releases electrical energy. Its high electrical conductivity and resistance to tarnishing make it an excellent material for capacitors. Palladium is also used in connectors, ensuring reliable and efficient electrical connection in electronic devices. In switches and relays, palladium coated contacts are commonly employed in switches and relays due to its low contact resistance and ability to withstand frequent switching without degradation. Chemical and pharmaceutical industry catalysis in chemical reaction. Palladium catalyst plays a crucial role in numerous chemical reactions. They are used in organic synthesis, hydrogenation processes, and cross-coupling reactions. Palladium catalysts enable efficient and selective transformations, contributing to the producing of pharmaceuticals, fine chemicals, and specialty compounds. Pharmaceutical synthesis. Palladium catalyzed reactions are employed in the synthesis of pharmaceutical compounds, helping to create complex molecular structure and improve efficiency in drug manufacturing. Hydrogen purification and storage. Palladium members are used for hydrogen purification and separation. The selective permeability of palladium to hydrogen allows it to separate and purify hydrogen gas from mixed gas streams, making it valuable in hydrogen production and purification processes. Palladium is also used in hydrogen storage materials, enabling the safe and efficient storage of hydrogen for fuel cell applications. Dentistry. Palladium based alloys are commonly used in dentistry for dental crowns, bridges, and other dental restorations. Palladium's biocompatibility, corrosion resistance, and strength make it excellent material choice for dental applications. In jewelry and precious material, palladium is used in the jewelry industry as a precious metal. It is often alloyed with other metals such as gold and silver to create white gold or used as a stand-alone metal in jewelry designs. Palladium's lustrous appearance, durability, and hypoallergenic properties make it an attractive option for jewelry. Detection of palladium. Palladium's color is very similar to platinum and it is impossible to detect the difference based solely on this. Palladium can also appear very close in color to high nickel white gold or rhodium plated white. The following methods will help determine if an atom is made in palladium for non-destructive testing. Iodine can be used to detect the difference between palladium, platinum, and white gold. Place a drop of it on the clean surface of unknown white metal. If you suspect that the item has been rhodium plated, use abrasives to remove plated surface in the area that you want to perform the test. As the small drop of iodine evaporates and dries, it will take on a body color that will assist in detection of metal. Here are most common reactions you can expect with a drop of iodine after it has dried. After seeing the test results, place the item in the palm of the hand to test its weight. If the drop near the colorless and the jewelry object feels heavy, it is likely that the sample is a platinum alloy. If the drop dries black and is questionably light for platinum, it is likely to be palladium. Destructive tests include heating the unknown object to determine if it loses its polished luster or takes on a blue-violet surface oxide. If the blue-violet color appears, it is possibly palladium. If it remains colorless and do not lose its polished luster, it is likely a common platinum alloy. But sure that the pieces are not rhodium plated, palladium will turn concentrated nitric acid to an orange-brown color. Platinum will not be affected and nickel alloy will turn the solution a greenish color. Here are the test results we can conclude after performing the test. When iodine is applied to palladium, if it is palladium, the iodine will turn black. If it is platinum, the iodine dries and the platinum remains in its color. If it is 9 carat, 14 carat, or 18 carat white gold, the iodine will turn brownish. Now we will discuss global palladium market. The globally palladium market encompasses the production, consumption, pricing, and trading of palladium metal. Let's explore the key aspects of global palladium market. Supply and demand dynamics. Mining and production. First of all, we will discuss palladium is a primarily mined as a byproduct of platinum and nickel mining. Major production countries include Russia, South Africa, and Canada. The supply of palladium is influenced by mining operation and production levels and factors such as geological constraints, labor issues, and environmental regulations. The second one is demand from industries. The demand for palladium is driven by various industries, with the automotive sector being the largest consumer. Other significant demand sources include electronics, chemical and pharmaceutical industries, dentistry, and jewelry. Changes in emissions regulations, technology advancements, and consumer preferences impact the demand for palladium in these sectors. The major producer and consumers of palladium are mentioned in the next point. First of all, Russia. Russia is the largest producer of palladium with significant reserves and strong mining industry. Major mining companies in Russia include Norilsk Nickel, which is a leading global producer of palladium. Second one is South Africa. South Africa is another major producer of palladium. The country has extensive platinum and palladium reserves, and mining companies like Anglo American Platinum and Impala Platinum are key players in the industry. Third one is China. China is a significant consumer of palladium driven by its automotive and electronics industries. It imports palladium to meet its domestic demand. Fourth one, United States, Europe, and other regions also contribute to both production and consumption of palladium. The next key point is price trends and market factors. Platinum prices are influenced by various factors including supply and demand dynamics, geopolitical events, economic conditions, and investor sentiment. Market speculation and investment. Platinum has gained attention as an investment asset, and fluctuation in investment demand can impact prices. Exchange Traded Funds (ETFs). Platinum's ETFs allow investors to gain exposure to metals price movements affecting demand and prices. Global economic conditions also play a role in price trends. Economic growth, particularly in emerging economies, affect the demand for palladium in industries such as automotives and electronics. Emissions regulation, changes in emission standards and regulations worldwide can significantly impact demand for palladium in automotive catalytic converters, trade and market infrastructure. Palladium is traded on common commodity exchanges such as London Metal Exchange and New York Mercantile Exchange, which is also known as NYMEX. These exchanges provide platform for future and option contracts, facilitating price discovery and risk management for market participants. Over the counter market (OTC). OTC trading occurs outside of exchange platform, enabling direct transaction between market participants, including product producers, consumers, and investors. Market participants. Market participants include producers, consumers, traders, speculators, and investors. The global palladium market is characterized by its close ties to industrial demand, particularly in automotive sector, while also being influenced by investment, demand, and market speculation. Fluctuation in supply and demand dynamics, geopolitical demand, economic conditions, and regulatory changes all play an important role in shaping the dynamics and pricing of the palladium market. Investment opportunities in palladium. Palladium is a precious metal that has gained significant attention in recent years due to its increasing demand in various industrial sectors. It is primarily used in automotive industry for catalytic converters which help reduce harmful emissions from vehicles. If you are considering investment opportunities in palladium, here are a few key points to consider. First of all, market demand. Palladium has experienced a surge in demand driven primarily by stricter emissions regulations worldwide. As governments pushes for cleaner air and lower emissions, the demand for palladium in catalytic converters has increased significantly. Limited supply. Palladium supply is relatively limited, with majority just coming from few countries like Russia and South Africa. This limited supply, coupled with increased demand, has contributed to price volatility and potential investment opportunities. Price performance. Palladium prices have shown substantial growth in recent years from around $500 per ounce in 2016 prices surpassed $2,800 per ounce in early 2020. While prices can be volatile, the upward trends reflect the market dynamic for increasing demand and limited supply. Diversification. Diversification. Palladium can serve as a diversification tool in investment portfolio. As a precious metal, it has a low correlation with traditional asset classes like stocks and bonds. Adding palladium to your portfolio can potentially provide a hedge against inflation and economic downturn. Investment instruments. There are several ways to invest in palladium depending upon your preferences and risk tolerance. The most direct approach is to purchase physical palladium in the form of parts or coins. However, it's essential to consider storage and security needs. Alternatively, you can invest in palladium through exchange trading funds (ETFs) or platinum future contracts, which provide exposure to price movement of the metal without physically owning it. Next one is market research. Before investing in palladium, it is crucial to conduct thorough market research and analysis. Stay updated with the latest industry news, supply demand dynamics, geopolitical factors, and other regulatory changes that could affect the palladium risk. Like an investment, palladium carries the price of palladium can be volatile, influenced by factors such as economic conditions, geopolitical events, and changes in automotive industry trends. Additionally, changes in regulation or advancements in alternative technology could affect the demand for palladium in the long run. It's important to note that investing in palladium, like any other investment, involves risk, and it is advisable to consult with a financial advisor or investment professional to assess your specific investment goals and to risk tolerance before making any investment decision. Now we will discuss environmental and sustainability implications of palladium. Palladium, like other precious metals, has environmental and sustainability implications throughout its life cycle, including extraction, production, usage, and disposal. Understanding these implications is crucial for mitigating environmental impact and promoting sustainability. Here are some key aspects to consider. First of all, mining and extraction. Palladium mining involves the extraction of ore from the earth. It can lead to deforestation, habitat destruction, and soil erosion. Mining activities may also result in the release of harmful chemicals and heavy metals into nearby water bodies, leading to water pollution and ecosystem damage. Now, energy consumption. The production and refining of palladium requires significant energy inputs, contributing to greenhouse gas emissions and climate change. To mitigate these impacts, efforts should be made to adopt energy efficient processes and utilize renewable energy sources in the production and refining stage. Emissions reduction. Palladium plays a crucial role in catalytic converters, which help reduce harmful emissions from vehicles, including carbon monoxide, nitrogen oxides, and hydrogen hydrocarbons. The widespread use of palladium in catalytic converters has contributed to significant improvement in air quality and reductions in vehicle emissions. Recycling and circular economy. Promoting the recycling and reuse of palladium can reduce the need for primary extraction and minimize the environmental impact associated with mining. Palladium can be recovered from various waste streams, including end-of-life vehicles, in electronic waste, and industrial application. Implementing efficient recycling technology and establishing proper collection and recycling infrastructure are essential for realizing the full potential of a circular economy for palladium. Responsible supply chain. Ensuring a responsible and ethical supply chain is critical for promoting sustainability in the palladium industry. Transparency, traceability, and adherence to international labor and environmental standards are key factors in reducing social and environmental risk. Stakeholder collaboration, certification program, and responsible sourcing initiatives can help promote sustainable practices across the palladium supply chain. Life cycle assessment. Conducting a comprehensive life cycle assessment of palladium from extraction to disposal can provide valuable insights into its environmental impacts. Life cycle assessments help identify hotspots in the production process and guide efforts to optimize resource efficiency, minimize waste generation, and reduce environmental burden. By addressing these environmental and sustainability implications, stakeholders in the palladium industry can contribute to the responsible and sustainable use of this precious metal while minimizing its environmental footprint. Now, I will discuss the future of palladium. Palladium, as a versatile precious metal, continue to experience exciting innovations and future trends across various industries. Here are some notable advancements and anticipated developments. First of all, sustainable catalysis. In recent years, there has been a growing focus on sustainable and greener catalytic processes. Palladium catalysts have demonstrated remarkable efficiency in facilitating environmentally friendly chemical reactions. Ongoing research aims to enhance the catalytic performance of palladium and explore its potential in new reaction pathways, enabling more sustainable chemical synthesis. Palladium in medicine. Palladium's potential in medical application is an emerging field of research. It exhibits promising antimicrobial properties, making it suitable for use in antimicrobial coatings for medical devices and surfaces. Conclusion. In conclusion, we have embarked on a journey through the remarkable world of palladium, a versatile and precious metal that often goes unnoticed compared to its counterparts. We have explored its properties, industrial application, investment potential, and future prospects. Palladium, with its exceptional physical and chemical properties, has found its place in various industries, from automotive catalytic converters to electronics and chemical and pharmaceutical sectors. Palladium plays a crucial role in enabling technological advancement, reducing emissions, and facilitating sustainable process. As an investment opportunity, Palladium offers unique advantages. Its limited supply and increasing demand driven by emission regulation and emerging technologies have resulted in significant price appreciation and the potential for diversification in investment portfolio. Looking to the future, Palladium continues to exhibit promising trends and innovation. Advances in sustainable catalysis, nanomaterial, energy storage, electronics, and healthcare open up new possibilities for palladium applications. Additionally, the exploration of palladium alloys and the emphasis on recycling contribute to a more sustainable and circular economy. This dynamic landscape, palladium remains a catalyst for progress, driving innovation and shaping industries. Its importance will continue to grow as we strive for cleaner technology, sustainable solutions, and a greener future. As we conclude this presentation, let us embrace the immense potential of radium and encourage future exploration, collaboration, and investment in this remarkable precious metal. Together, we can unlock its power and pave the way for a brighter and more sustainable tomorrow. Here are the references links through which you can visit and explore more about the palladium metal. Now I will end up my presentation. Hope you enjoyed it. Allah Hafiz.